Okay, so now we're going to do some graphing, and we've done this before. I just want to show you some things. Notice in this case we have a slope that is negative, so that's why the line is going down as we go left to right. We have a b value, which is 0.3. Notice that that is about 0.3 or a third around that particular value. What you can see is if we change m, watch, so when m starts going positive, you can see that it changes direction. Of course, it goes up. The higher the number, the bigger the slope. So that means it's going up faster. And so that's what's happening with that particular one. And now let's see what happens to B. So if B goes up, notice how the y-intercept just goes up. And notice if it goes negative, then it just goes down, right? Doesn't change the slope, doesn't change anything. It just changes that one. So that's all that we're doing when we're looking at those particular ones. So graphing linear functions in slope-intercept form. So notice that we have an equation here. We have a slope of 2/5 and a y-intercept of 1. So we're going to go ahead and put in our y-intercept. So we're going to move our equation up to 1 is what we should have done. Okay, there we go. So our y-intercept is at 1. That's what this point is. This 2/5, if you remember, because it's positive, we're going to go up 2, 1, 2, and we always go to the right. 1, 2, 3, 4, 5. So we're going to come right over here. So we're going to do another point, and we're going to drag that over to there. Not at 2, 5. We're going from this point up 2, and then we're going over 5. And then we're going to draw a line in between those two. So we're just going to match up those points. We're going to match that one with that one. And we're going to match that one with that one. And then we're going to check the answer. Thought I hit it. Well, it doesn't say anything, but that's what it should be. So the answer should look like that. Let's just check it to verify what's happening there. I don't know why it didn't do the check my answer. And it looks just like that equation, right? We can see it goes through 2, and then it goes through, notice here, it doesn't even go all the way up to 5, but it hits 5 right there. So we can see that part of the line right there. Okay, next one, graphing linear functions. We're going to go ahead and do an example here. So we have negative 4x plus 8y equals 16. Before we get started, we have to go through and we have to graph that. We have to solve for y. So to solve for y, I'm going to add 4x to both sides. So if I add 4x to both sides, that's a plus. These two, of course, cancel. We have 8y equals 4x, since it's positive, plus 16. We're then going to divide everything by 8. Those two cancel. We want the y all by itself. Of course, this reduces down, so we have y equals, and 4 over 8 is really 1/2 x, and 16 over 8 is just 2. So here we have a point. So let me reduce this down a little bit so we can draw it a little bit nicer. So notice up there we have a 2. So that's my y-intercept. So my y-intercept is going to be located right about there. Okay, we'll make it a little bit bigger once I get this done. And then remember that this means go up 1 and over 2. So here's our point. We go up 1 over 2. So I just have to go to that point right there. I don't have to keep making a whole bunch of other points. I really only need 2 points for a line. Let's go back to 100%, and that way we can see those points. And I'm going to draw a line, and hopefully a straight line, that goes through those 2 points and comes down through the other ones. So it goes down the other way. Okay. And so that's what we have when we're drawing that particular line. So notice it looks like that. It goes through 2, up 1 over 2. And so notice here, it's got to go through 2, up 1 over 2. It's got to be D. So D has to be the answer. And notice that D is our answer. Okay. Now we're going to go to graphing constant functions, and you've done this one before as well in the last section. So we want to graph y equals 2. So remember, when graph y equals 2, there is no slope. That is the y-intercept because there is no x value, right? So normally we would have y equals mx plus b, but m is 0 because that's what gets rid of the x value out of the equation. So that's what we're going to do on that one. I don't know what this is. So the slope of y equals 2 is 0. That's what I just talked about. And then we can go through and put everything through. So we're going to go ahead and put our point here at 2. Okay, that's where we're going to put our point. We're going to go ahead and do our line. So we're going to put one of the points there at 2. And all we have to do is just put another point at 2 anywhere along that line. There's our line that we have there. Yes, we can check the answer. We can also see the answer. You'll notice that it's a straight line that's horizontal going through the point 2. Okay, just like we drew up here. Okay. And then how do we know the graph has a slope of 0? Well, if you look at it, it's neither going up or down. So therefore the slope has to be 0. It has to be staying the same all the way through. Okay. Next one. Let's go to the next slide. So the next slide tells us we want to graph constant functions. Again, I think. I don't know why we're doing this again, but we can. Y at -5, so -5 is down here, so it's going to be a graph that's going to go right across that part right there. So I'm going to kind of just skip over that because we don't need it. And then what we're going to do is we're going to go right into the check. But I did want to point out that if you have a question, there's a video at the end of the presentation that will also help you learn what the slope-intercept form is. And we're done with this lesson.